So, just because of the material that we're going over today, I'm not going to give you any in-class problems because I kind of need pretty much most of that time. I also wanted to go over the exam really quickly. Uh, what are the three things that I've been trying to tell all of you quite a bit? Negative times a negative is a, um, if if you're trying to factor something, what can you do? Graph it, then math it. And three, do we like fractions? Hell no. So how do you get rid of fractions? Multiply by the biggest denominator that you have. So with the first problem here, it, instead of graphing it and then mathing it, you can matrix this, then math it. Most of you forgot how to do that. Uh, but when you go to math it, call those equations A, B, and C. Based on what I'm looking at when I'm staring at this, I look at those and I say, those are the easiest things to get rid of. Let's get rid of Z. So you end up with A plus B gives you a new equation D. B plus C gives you a new equation E. Then to eliminate X or Y, we have something times D plus something else times E. Honestly, I don't remember what those numbers are, but that's a thing. Okay. And you could also use the matrix function in your calculator so that you know what you should be getting. So if you started to get like a negative 47.63824, blah, blah, you knew that you did something wrong. Although I would guess that while you're doing the problem and you get something like that, you're going to think, yeah, I did something wrong, but I don't know what. With this, again, based on some of the stuff you're talking about, I can rewrite the first part here like that. I can rewrite the second part. And when you go and you uh, try to eliminate these, you can either do it as, say, x to the 8 minus 13, and then y to the 7 minus 9, 8 minus 13, negative 5. Since that's in the numerator, you drop it to the denominator. So there you go with that. Same type of issue with this one. This, you just put it in the calculator and you get the correct answer. If you wanted to try to fake it, you could do that too. Uh, here, it's you're foiling, but you're going 7y squared times 9y squared, 7y squared times negative 9y, 7y squared times negative 6, negative y times all three, then negative 4 times all three of those. And that's the one where I said I did the problem myself and then did it wrong, and then had to go back and redo it. So I didn't take as many points off of there as I should have. For this one, is there a common numeric value I can pull out of these? What's a common numeric value in 25 and 35? At least 5, right? What's the largest value of u that I can pull out of both of these? It's going to be u squared. Largest value of y I can pull out of both of these. It's going to be y squared. So that's where the front part should be. For both of those, if you remember to do it as factor by grouping, what's the common theme in these two? z squared. What's left over? Z plus 5. What's the common factor in these two? What's left over? So you could have done it like that. But this is a factoring thing. So what else could you have done? Graphed it. Seen about where these numbers are going to come out to give you an idea of what you should be looking at. Here, use the quadratic formula. A lot of you tried to use whatever other formulas you had. Like I said, the quadratic formula works in all of these cases, all the time, every time, always. A lot of the stuff that you've been taught in other classes doesn't quite work on these. But again, it's factoring, so how could you have figured it out? Graph it, right? This one, and this is actually something that we're going to be going over today. So a squared minus b squared. It's a minus b times a plus b. In this case, a is going to be the square root of 49t to the fourth. So 7t squared. B is going to be the square root of 4u squared. So it's going to be 2u. And then plug them in. Okay. With this one, because we're looking at a squared or a cubed minus b cubed, a is going to be the square root of 64r cubed. So square root of 64, or sorry, cubed root of 64r cubed, and then the cubed root of r cubed. Cubed root of 64, 4 cubed root of r cubed is r. B cubed root of negative 125, or actually just 125. So it's going to be 5. And again, with that one, graph it. Or you could have graphed it. So far we've got 1, 2, 3 problems where you could have graphed it and gotten at least an idea about what the right answers are. This one, graph it. You can graph it if you want to. You have to rewrite this one, but you can graph this one. This is the one I was talking about where some of you did it completely the wrong way, but you still came up with the right answer. And I actually posted what some of you did on a chat board and asked, so how do I grade this? They're like, well, they got the right answer. I guess this was a special case where it worked. Like, oh, okay, I'll go with that. So if you did look at this and rewrite this as 16x squared minus 21 squared, I believe that's what, 441. That is totally wrong way of doing it, but you get the right answer. One of the big issues that came up with this is if I have 5 over 5 minus a, that's the same thing as negative 5 over a minus 5. If you remember that trick, you now have the same denominator here. So you have 6 minus 5 over a minus 5. What's 6 minus 5? Just one. With this one, do we like fractions? No. So how do you get rid of the fractions? You basically have to cross multiply and it becomes a mess. But essentially you end up with 3 times a minus 10 minus 2 times a plus 9 divided by a plus 9, a minus 10 in the denominator. If you FOILed the denominator, cool. If you didn't, don't worry about it. This one gave a lot, or some of you, a bit of fit. But again, we can graph these to figure out what they factor out to, and then we can also start eliminating things and get rid of things in the denominators here, make it a lot easier on ourselves. I will say one of the big sticking points here was this first part. 12 and 4, so I can at least pull out a 4, m and then m squared, so I can pull out the m. 12m divided by 4m, that's going to be 3. 4m squared, pull out a 4m. We have to use that same idea we had earlier. Once you see that, it eliminates with some of the stuff that's over here and makes things a whole lot easier. With this one, do we like fractions? No. So on the top, you end up with x squared minus 4 divided by 4x squared. With the denominator, and then you flip it, factor that. The x plus 2 cancels out with the x plus 2 here, so you have x minus 2 up on the top. 2x cancels out with 4x squared, so things happen there. Do we like fractions? No, we don't. How do we deal with fractions? Multiply by the biggest denominator. That'll cancel out the b plus 9 here. And then we've still got b minus 3. So at some point, you end up with 2 times b plus 9 plus 8 times b minus 3 equals b plus 9 times b minus 3. And going to be honest, that looks like a mess, right? If we take it and we graph that, you get answers. So this is another one where you can graph it before you try to math it. So again, here, you could graph each one of these to see how it breaks down if you don't see it instantly. With this last one, do we like fractions? No, we don't. How do we get rid of a fraction? Multiply by the biggest denominator that we have. When you do that, you get 3 times b minus 4 plus 4 times b equals 16. Then you can solve it. You can also look at this. So that should actually be a 4b right there. Just as it is, graph it. You'll see where it comes through. With the extra credit, what can you do with the extra credit problem that's right there? Graph it, right? With the extra credit here, you want to know what the domain is. Stuff on the denominator tells you what the domain is. If you don't see how to factor that instantly to get the values of x, what can you do? Graph it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. 10 out of 18 problems if you graphed them, or you could have graphed them eventually and figured out what the answer should be, or getting the idea at least about what the answer should be. So, yeah, that was a thing. Anyone glad they don't have to do that again? Anyone a break right now? All right. So, based on what we get to do today, section 8.4 and 8.5 out of the book, a lot of this gets to be repetitive. So we'll do a couple of the simpler ones and then try to focus a little more on the more complicated ones. So just as an example, looking at, oops, need to share my screen. So if we're looking at like this, 8 times the square root of 2 minus 9 times the square root of 2. Once, and you can do the same trick with literally all 6 of the problems that are on here. Like I said, these are, you can spend some more time on the more complicated ones. So what number do these two things have in common? It's the square root of 2. So I can rewrite this as 8 minus 9 times the square root of 2. 8 minus 9 is negative 1 times the square root of 2, or just the negative square root of 2. If you try to factor the other 5 things here, cube root of x, cube root of x, that gets factored out. We have 4 plus 7, 4 plus 7, 11. 11 times what? 11 times cube root of x. Here, got the 4th root of x, 4th root of y. There's nothing we can really factor out there. So how do you factor that? You leave it. Easy enough, right? If this was, let's say 10 minus 5, then you could say potentially pull out the 5 and do something with it. But just the way that it is, nothing we can really do. Looking at these, remove the, or factor out the square root of 3. So 5 minus 9 is negative 4. Negative 4 times the square root of 3. Here, 5 plus 3 going to give you 8, and then 8 times the thing that you factored out, which is the cube root of y. Again, there's nothing here that you can really do anything with. So you're just done. Looking at a couple of these, same basic idea. Up front here, we have square root of 7x, square root of 7x, square root of 7x. We can pull the square root of 7x out from all of these. So this becomes 1 minus 7 plus 4. So 1 minus 7 is -6. -6 plus 4 is -2. -2 times the square root of 7x. Here, all of these have the fourth root of 5xy. So you can factor out fourth root of 5xy. End up with 4 plus 2 minus 7. So 4 plus 2 is 6. 6 minus 7 is -1. So we have negative fourth root of 5xy. Same thing with these guys down here. Now it's with some of these here where things get, I don't know, is icky a proper term? Yes. So we've got square root of 18 plus 6 times the square root of 2. And then we have 6 times the cubed root of 16 minus 2 times the cubed root of 250. And then 2/3 times the cubed root of 81 minus 1/2 times the cubed root of 24. These are a little bit more ick, I guess. They are quite a bit trickier. So let's see what's going on with all of these. So square root of 18 plus 6 times the square root of 2. Then I've got 6 times the cubed root of 16 minus 2 times the cubed root of 250. And the final one is 2/3 times the cubed root of 81 minus 1/2 times the cubed root of 24. So with all of these, we want to have the same basic idea. We look here, we've got a square root of 2. Here we've got a square root of 18. Probably want to do something where you can get a square root of 2 out of here. So 9 times 2 is 18. Square root of 9 times square root of 2 plus 6 times square root of 2. Square root of 9 is going to be 3. Square root of 2 plus 6. Square root of 2. Now this looks a lot like one of the problems we had at the beginning. Factor out the square root of 2. We got 3 plus 6 out in front. So not too horrific here. So you just end up with 9 square root of 2. Up here, again, I don't see anything instantly. But I'm seeing that maybe I can pull a cubed root of 2 out of both of these. So my first step, cubed root of 8 times 2 minus 2 times the cubed root of 125 times 2. So this becomes 6 times the cubed root of 8 times the cubed root of 2 minus 2 times the cubed root of 125 times the cubed root of 2. Cubed root of 8 just going to be 2. And then we have this cube root of 2 out here. Not much I can do with it yet. Now I have 2. What's the cube root of 125? It's going to be 5. And then the cube root of 2 here. 6 times 2, 12. Cube root of 2 minus 2 times 5, so 10. Cube root of 2. 12 minus 10, 2. Cube root of 2. Over here, probably going to run out of room, but same idea. My first step, cube root of 27 times 3 over here, minus 1/2, then the cube root of 8 times 3. Cube root of 27 is 3, cube root of 8 is 2. So this will become 2/3. So cube root of 27 is 3. And then we still have the cube root of 3 left over. Then here we have 1/2. Cube root of 8 is going to be 2. And then I've also got to have the cube root of 3 at the end. 3 on top, 3 on the bottom, cancels out. 2 on top, 2 on the bottom, that cancels out. So we end up with eventually 2 times the cube root of 3 minus the cube root of 3. This is the same as saying 2 minus 1 times the cube root of 3, which at the end is just going to give you the cube root of 3. So a whole lot of stuff going on there. And as you would expect, because this is a math class after all, everything does get worse because it's math. It's got to get worse, right? If things got better, then you'd start looking at round funny, wouldn't you? So take a quick, we'll look at uh 77 A and B. With all of these, we have to have essentially the same idea. Can we find a common theme among the roots? Sometimes we can, sometimes we can't. And for the other one, we've got what? The cubed root of 135, x to the 7 minus the cubed root of 40, x to the 7. Okay. So with all of these, we want to try to find a way that, because I've got a square root here, try to find a way to make these a square times some other number. Because I've got cubes here, I want to try to make these numbers a cube times some other number. Looking at what I have here, keeping in mind that I want to have squares, I can say 16 times 2. This m to the 7, I'm actually going to break that down as m to the 6 times m minus square root 25 times 2. And they both have m to the 7, so I could even make that, say, m to the 11 if I really, really wanted to. The same idea is going to apply here. You can have m to the 10 times m, square root of 16, square root of 2, square root of m to the 6, square root of m, minus square root of 25, square root of 2, square root of m to the 10, square root of m, square root of 16 is 4, square root of 2, just going to be the square root of 2, square root of m to the 6 is going to be m cubed. If you don't remember where that comes from, or going to do basically the same thing over here, keep in mind, let's say the square roots of x to the 8, I can rewrite that as x to the 8 to the 1/2 power. So I get x to the 8 over 2 power. So I can get x to the 4th. Same thing happening here. M to the 6 times the 1/2 power gives me m to the 6 divided by 2 power, which is 3. Then I just have square root of m there. Minus square root of 25 is 5. Square root of 2 is 2. Square root of m10 is m to the 5th square root of m. Now, when I look at all of this, 4m cubed, then I've got the square root of 2m left over. And then out here I have 5m to the 5th square root of 2m. So if I need to factor this the way that it is, what do I have that's common between these two? They both have square root of 2m. What's the largest value of m that I can pull out of both of these? It's going to be m cubed. And then what's left over? I'm going to have a 4 there minus, I've got m to the 5th, but I pulled out an m cubed. So I can do that. If I kept this as a 7, instead of m to the 5th, you'd have m to the 3rd. So you'd have 4 m to the 3rd times the square root of 2m minus 5 m to the 3rd times the square root of 2m. 4 minus 5 is 1, or negative 1. So we'd have a little bit different answer, but we got a little bit harder problem than we had before. So not going to worry about that too much. Yeah.
M1 in the beginning.
So 6 and 1. Why? Because I've got this invisible 2 that's up here. So I want the power up here to be power of 2. If we look at what I've got here, because I've got a cube, I'm going to break down x to the 7th as x to the 6 times x. With both of these. Why? Because I want the power to be multiple. So that's the only reason why this is happening. Since I've got made it m to the 11 here, m to the 10 times m, 10 plus 1 is 11. 10 divided by 2 is 5. Some of these are going to get worse than that. So, just saying. So, since I kind of ran out of room there, I'm going to rewrite this one. So cubed root of 135 x to the 7 minus cubed root of 40 x to the 7. So again, what I want to do is break this down into something where I'm going to have a cube times a certain value. And I'm looking at this, I have no idea what that's actually going to be. But I know because I've got x to the 7, I'm going to break it down like that. Now, if I'm lucky, I can look over here and I can look at 40 and I can ask myself, what are some values I can multiply to give me 40, where one of them is a cube? That's going to tell me 8 times 5. Again, I want to do x to the 6 times x. Okay. Since I've got the 5 over here, I know I can pull a 5 out of here. That's going to tell me right here, right now, 135 divided by 5. What is that? So 135 divided by 5 gives us 27. So sometimes we get lucky like that, sometimes not so much. So again, break these down. Cubed root of 27, cubed root of 5, cubed root of x to the 6, cubed root of x, minus cubed root of 8, cubed root of 5, cubed root of x to the 6, cubed root of x, cubed root of 27 is 3, cubed root of 5 is going to be the cubed root of 5, cubed root of x to the 6, x squared, cubed root of x, it's just going to be cubed root of x, cubed root of 8, 2, cubed root of 5, just going to be cubed root of 5, cubed root of x to the 6, that's going to be x squared, cubed root of x. It's just going to be the cubed root of x. So we now end up with 3x squared times the cubed root of 5x minus 2x squared times the cubed root of 5x. What do these two things have in common? Factor that stuff out. 3 minus 2 is just 1, which means that that is what we're going to be left with. Does that look like a mess? Yes, it does. Does it get worse than that? Yes, it does. If you're looking at some of these and you don't see exactly what you're supposed to be doing, so like here, I took m to the 7, made it m to the 6 times m. I took m to the 11, made it m to the 10 times m. Here, I made it x to the 6 times x to the 1. Something else that you can do with that And let's just say we had something like the fifth roots of x to the 28 power, something like that. So something totally bizarre. You can follow if you understand what's going on here. You can rewrite this as fifth root of x to the 25 times x cubed. That breaks down as the fifth root of x 25 times the fifth root of x cubed. Nothing I can really do here, but this is going to be basically become x to the fifth. If you see that, awesome. What happens if you don't? Well, we need all the exponents to add up to 28. So the other option, x to the 5 times 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 x to the 3. So 5, 10, 15, 20, 25. Break that down. Oops. Sorry. Break that down as the fifth root of x to the 5 times fifth root 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 x cubed. All of these will just give you x. X times x times x times x times x is x to the fifth root x cubed. So a couple different ways you can try to solve the exact same problem. If you see what's going on and you understand what's going on really quickly, awesome. If you don't, you can still get there. It's just, if you see what's going on from here, one step, two step, basically done. If you don't, initial step, first step, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13. Do you still get there? Yeah. Does it take you a little bit longer? Yeah. But so that's what the answer should be for both of these. But as long as you get the right answer, if it takes you a little bit longer, are you willing to spend a little more time to get that right answer? I would hope so. So one of the things that I've actually noticed about, like, say, the A students and the B students, and then the B students versus the C students, a lot of times the A students will see some of these shortcuts that I'm talking about. They can take advantage of them and then just do it. Good for them. With the B students, they don't see that shortcut, so they do the little bit longer route. And the more steps you do, the more likely you are to make a mistake. But with all these problems, it's what, 5 or 6 points. Generally 3 points for work, 2 points for the answer. So even if you do make a mistake somewhere and you take a longer route, you're still going to get some decent points. Then the C students do the longer route and really, really mess it up. Which means they end up usually with only, say, 1 point on a particular problem like that. So just looking at like what we've got here for these ones, because I've got the cubed root out in front and I've got y to the fifth here, I'm going to break that down to y cubed times y squared. I've got n to the fifth here. This is going to be n cubed times n squared. And then, of course, I'm going to try to break down the 256 into a number that is a cube times something. Over here, I'm going to break 32 into a value that is a cube times something. What comes to mind instantly when you think about factors of 256 where one of them is a cubed? I have no idea. But what are some factors of 32 where one of them is a perfect cube? So what are the perfect cubes that we've dealt with? 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So in this case, I'd go with 8. 8 times 4. Cubed root of 8 is going to give me 2. So there's going to be a 4 left over. That's giving me a hint that I should probably try to divide 256 by 4 and hopefully get a happy number. Not sure if you do, but there is one way to find out. So 256 divided by 4, 64. Is 64 a perfect cube? Yep. So I can use that. So with these two, or with all this stuff here, because we're going to be multiplying a couple different ways we can go about this, I honestly don't know what's going to be the easier way to work with this. So going to do it 2 different ways, and then you can decide what you want to do when you see these types of problems, okay? So I'm just going to do 880 A and B. So I've got 3 root 3 times 3 root 6. Going to work on this one first just so we can see kind of what's going on here. Hopefully make the next one a little bit easier to deal with. So this really is a 3 out in front. I can multiply it all together and get 3 times 3, so 9 square root of 18. If I take the square root of 18, do I get a happy number? No. But I can say 9 times the square root of 9 times 2. And then 9 times the square root of 9 times the square root of 2. What is the square root of 9? 3. So I can say 9 times 3 times square root of 2. 9 times 3, 27 root 2. Yay us. Another way that I can look at this is 3 root 3 times 3 root 3 times root 2. 3 times 3 is 9. Then we have square root of 3 times square root of 3 times square root of 2. Square root of 3 times square root of 3. It's going to give me the square root of 3 squared. Square root of 3 squared It's going to be 3. I don't know what you like better, but it is 2 different ways that we can try to do this. Again, if you can, as long as you can get the right answer, doing it on your own, I don't really care what method you use. What makes more sense to you? What's going to be something that's going to be easier for you to remember when you're working on all of this? I don't know. You tell you. Okay. With the next problem that we have on here. So it's basically the same one or the same type of problem, I should say. So I've got -4 times the cubed root of 9 times 3 times the cubed root of 6. So again, I can take this and say -4 times 3 times the cubed root of 9 times 6. What's 9 times 6? So now I've got 54. What is a value or a number that we can put in here where one of them is going to be a cube, the other one doesn't have to be? If we recognize it, awesome. So -4 times 3, it's going to be -12. Then we can do the cubed root of 27 times 2. Cubed root of 27, it's going to be 3 times the cubed root of 2. -12 times 3. There we go. Using the other method like it was doing up here, can rewrite this as -4 times the cubed root of 3 times 3, and then 3 times the cubed root of 3 times 2. Multiply the whole numbers or the numbers that are outside of the radical together. So -4 times 3, everything under the root. So cubed root of 3 times 3 times 3 times 2. -4 times 3 is again -12. Cubed root of 3 cubed times 2. So this becomes -12 times 3 times the cubed root of 2. So it's the exact same thing. Again, which one of these methods works best for you? Use it. I don't care how you get the right answer, as long as you get the right answer by doing it yourself, okay? And that's probably going to be another thing you get tired of listening to me say. And then what's going to happen on the next exam? You can ask negative times a negative is a what? Do we like fractions? No. So how do we get rid of them? Multiply by the biggest denominator, graph it, then math it. And then the fourth one's gonna be, I don't care how you get the right answer as long as you do it on your own. So. Looking at the way that some of these are actually going to be set up. So again, we've got some options here. We can multiply the numbers that are outside of the root together, and multiply everything that's under the root together. Hopefully we can pull apart something like that. Or we can start pulling things apart and see what happens. It's basically the same thing as what we've been doing, except we've got variables in there instead. So let's look at a 882B. Definitely trying to live very dangerously. So we have -4, fourth root of 9a cubed times 3, and then the fourth root of 27a squared. So again, take everything, multiply the numbers that are outside of it, or outside of the root. Because these are both to the fourth root, I can say fourth root of 9 times 27 times a cubed times a squared. We want to have something that's a fourth root here. 3 cubed, 2 cubed. Or 3 squared times 3 cubed. So this actually becomes 3 to the 5th power. This is going to become a3, a2. So fourth root, none of this stuff's just going to follow along here. 3 to the 5th, a to the 5th, follow along one more time. So fourth root, 3 to the 4th times 3, a to the 4th times a. Fourth root of 3 to the 4th is going to be 3. Fourth root of a to the 4th is going to be a. And then we have left over fourth root 3a plus whatever we had out in front. So -12 times 3, -36a, fourth root of 3a. And every single step there is totally abundantly clear, right? So can these get to be pretty horrific? Yes, they can. But we still have to have the same idea. Since I've got a fourth root out here, what do I want? I want to have numbers under there where I can have a fourth. If this was, instead of a fourth root for both of these, if this was just squared, what am I going to do? 9 squared, or square root of 9, easy enough. Square root of a cubed, break that down to a squared times a. Again, over here, if I had squared here, take the 27, break it down to 9 times 3. So that I could take the square root of 9 and have a happy number. It's all about trying to match whatever power is here with the power in here. Sometimes you can do it, sometimes you can't. So looking at some of these, distribute the values so you can see kind of what they're doing here. And eventually you can start eliminating things. So if we look at like 884A, so the problem is square root of 8 times 2 minus 5 times the square root of 8. This is going to give us 2 times the square root of 8 minus 5 times the square root of 8. But that's going to be squared. Square root of 8 times square root of 8. So we look to this, we get to rewrite it. It's 2 times the root of 4 times 2 minus 5 square root of 8 squared. It's going to be 8. 5 times 8. It's going to be 40. So this breaks down to 2 times the square root of 4 times the square root of 2. Square root of 4 is 2. So this will be 2 times 2 times the square root of 2. 2 times 2 is 4. So this whole thing, 4 square root of 2 minus 40. Now looking at what we have here, is there any way we can factor this? I'll just say these are equivalent to each other. So do we, again, on the exam, if you have a problem like that and you give it to me like that, totally fine with it. If you're dealing with the online system, it probably wants the other answer. I know that there's some of you that have had this class before. I have no idea what your other professors wanted, but more than likely, if you did take this class before, they're going to want you to break it down like that. I'm not going to worry about it that too much. With some of these right here, just comes down to basic foiling. We are going to be doing some of this sort of, excuse me, some of this sort of stuff in the next section, so I'm going to just skip ahead. So now we've got foiling again, but this time the foiling is even more horrific than it was before. So let's take a look at 87. So I've got 5 times the square root of 3 minus square root of 7, and then the square root of 3 plus 2 times the square root of 7. Hopefully everyone remembers FOIL. So first, 5 times the square root of 3 times the square root of 3. Outer, so 5 square root of 3 times 2 square root of 7. Inner, minus square root of 7 times square root of 3. And then last, negative square root of 7 times 2 square root of 7. So 5 square root of 3 times square root of 3. This is going to give us 5 times 3. 5 times the square root of 3 times 2 times the square root of 7. 5 times 2. 10 square root of 3 times 7 is 21. Minus square root of 21 minus square root of 7 times the square root of 7. So this is going to give us 2 times 7. 5 times 3 is 15 minus 2 times 7. So 14. 10 root 21 minus square root of 21. So we get that. Collect the like terms. So the whole numbers without any radicals in them. 15 minus 14 is 1. Plus 10 minus 1, 9 square root of 21. Does everyone remember how to FOIL? Maybe, maybe not. I'm sorry? Well, first, outer, inner, last. So this is like one of the expanded problem that we had here. So it's basically anytime we expand, if I had, say, 6 different things here, just as an example. So if I had something like that, I could still use the FOIL idea, but I'd have first, then first times the middle, first times the last, middle times the first, middle times middle, middle times last, last times first, last times middle, and then last times last. If we have so 6 things like that, dear God, it just got horrible, didn't it? But it's still going to be combining these first two. We're going to have G times I plus G times J plus H times I plus H times J. And then the first times the first, the next times the first, next times the first, next times the first, and then everything times the last, or first times first, first times last, second times first, second times last, third times first, third times last, fourth times first, fourth times last. It does not matter. We just have to make sure that basically you distribute the K to everything. And then you distribute the L to everything. So if we look at it as, say, just multiplying everything by K initially, then uh, go back here and do basically the same thing, but replace all the K's with L's. And you add all those together, and you've got, what, 8 terms? So 1, 2, 3, 4, 5, 6, 7, 8. How many terms are in each one of these things? 2 to the 3 terms. Here it's 1, 2, 3, 4, 5, 6, 7, 8, 9. How many terms do we have here? So yeah, the thing. One of the reasons why I mentioned FOIL is when you look at the next section that's in here. So again, these are special terms, special products. If you know what these are going to be because you memorize these special forms, awesome. Use it. If you don't know what these special forms are and you totally don't remember any of these, what do? FOIL. Okay. So keeping in mind so if we look at these two, we have something plus something, and then that whole quantity is squared. So something plus something else, that whole quantity squared. If we recognize that A is 2 and B is the square root of 3, we can plug it into our formula here, get our answer. Here, A minus B, and that whole quantity squared. There we go. So just so that since there are some issues with trying to use formulas like these on the exam, I'm going to write down the appropriate one here. So A minus B squared is equal to A squared minus 2AB plus B squared. So again, I'm going to do this 2 ways. One using the formula just so we can see what's going on. One of these I'm going to use just foiling just to see what happens. So look like a very familiar problem. Like one that was on the exam that you guys just did. So I said on the exam, some of you went about it like this. You squared everything in the first, squared everything in the end, and then canceled out and were able to get the right answer. If you did I'll use the formula like we have it here. We have A equals 4x, B equals 21. So I can use this formula here. So A squared It's going to be 4x squared. B squared is going to be 21 squared. So from here, using the formula, 4 squared, 16x squared minus 2 times A times B plus B squared. So we look up here. If you did the FOIL stuff correctly, what you should have gotten was 16x squared minus 2 times 4 times 21. I'm not even going to try to do that one in my head. So 2 times 4 times 21. So 186x. Oops, sorry, 168x. Plus, I believe that was 441. So that's what you should have got. And then on the exam, if you did that, you could have graphed it and come up with the correct answer. On the other hand, let's say you don't memorize these special formulas. All that you remember is FOIL. So 4x minus 21 squared is the same thing as saying 4x minus 21 times 4x minus 21. So first, outer, inner, and then last. Now, if you look at the formula up here, a squared, I said a is 4x times 4x. It's going to be a 4x quantity squared. They've got the 2ab. Well, here's a times b, here's a times b, and then there's 2 of them. And then b squared, 21 times 21 is 21 squared. So this gives you 16x squared minus 84x minus 84x plus 441. Combine the like terms. So you can try to memorize those formulas, or you can just use FOIL. And again, FOIL works with all of these. The special things that they show you only work at special times. Kind of like the quadratic formula that I showed you guys. It works on all quadratics. Are there easier ways to do some of the quadratics? Hell yeah. But if you can't remember how to do it, or if you can't figure out how to do it using a simpler method, by all means, use the quadratic formula. And then look at all these lovely problems here. And then we still have one more section to go through today. Horrible, I know. A lot of this, if you kept up with most of what I was doing in the other section, these actually aren't too bad. So let's take a quick look at 893b. So I've got the cubed root of 56a divided by cubed root of 7a to the fourth power. So again, a couple different ways we can actually try to do this one. So what's 56 divided by 7? So those have been canceled out to give us that. A on top, a to the fourth on the bottom. It's going to give us a to the 3. If you're looking at that and you're trying to figure out where did that actually come from, we can look at, say, a to the fourth power divided by a to the ninth power. We'd get a to the 4 minus 9, which would be a to the negative 5, which is 1 over a to the 5. Oops, that should be a cubed root. So we now have cubed root of 8 divided by cubed root of a cubed. So sometimes it is. You can do it the way that I just did it. If you don't see like all of these different steps here, you can say cubed root of a 56a is going to be, again, cubed root. Break down the 56, so I have one value that's a cube and another value that's not. The only ones that work here are 8 and 7. Here, cubed root of 7a cubed, or a to the fourth. We can break that down as the cubed root of 7, a to the third, a. So where does that 3 come from? It's because I got a 3 right there. Then break it down piece by piece. Cubed root of 8, cubed root of 7, cubed root of a, divided by cubed root of 7, cubed root of a, and then also cubed root of a cubed. Cubed root of 7 divided by cubed root of 7 cancels out. Cubed root of a divided by cubed root of a cancels out, which gives us cubed root of 8 divided by cubed root of a cubed, which gives us exactly the same thing as we had before. So which way works better for you? Again, you need to figure that out. So do I like have a really huge booger hanging from my nose, or did I do some math wrong somewhere? So anyway, like I said, I'm not going to give in-class problem for this because there are a bunch more of these types of problems to work on. Going to try to do them as, say, quickly as possible. So I'm going to look at number 95. So I have the square root of 162, x to the 10, y squared, divided by the square root of 2, x to the 6, y to the 6. And so we put everything under the root. One hundred 62 divided by 2 is going to be 81. X to the 10 divided by x to the 6 is going to be x to the 4. Y to the 2 divided by y to the 6 is going to be y to the 4. Take the square root of each one of these. 9x squared over y squared. If you want to try to do those out differently, you can. If you look at b again really quickly. So cubed root, negative 128, x squared, y to the negative 1, divided by cubed root 2x to the negative 1, y squared. So again, make this a cubed root, negative 128 divided by 2, x squared, y to the negative 1 is going to give us a y in the denominator. X to the negative 1 in the denominator is going to give us an x to the 1 in the numerator. So cubed root of negative 128 divided by 2, 64. X squared times x, it's going to be x cubed. Y times y squared, it's going to be y cubed. Negative 64 cubed, negative 4. Cubed root of x cubed, x. Cubed root of y cubed, it's going to be y. And there we go. So same idea here, start eliminating things. And then I'll eliminate things and pull them apart as best we can. So square root of 64 is going to be what? 8. Square root of x to the 4, x squared, square root of y to the 5th, y squared, square root of y. Maybe we can use that, maybe not. We put it all under the same radical. We can do the same process we've been doing, and we will eventually get there. Now, the big thing to deal with in here are actually problems like these. So one of the big issues that we have with these is how do we get the radical out of the denominator? Looking at 99a, if you multiply top and bottom by square root of 3, you get square root of 3 times square root of 3 becomes 3. No more radical in the denominator, but you have 5 times the square root of 3 in the numerator. How do we get rid of the square root of 5 here? Multiply by square root of 5 divided by square root of 5. Denominator is now 5, 6 times the square root of 5. Looking at C, 2 divided by square root of 2x. Multiply numerator and denominator by square root of 2x. Your new denominator will become 2x. The numerator is 2 times square root of 2x. You then have 2 in the numerator, 2 in the denominator that cancel out. Square root of 2x divided by x. Same thing here, 5 divided by square root of 5x. Multiply numerator and denominator by square root of 5x. You have 5x on the bottom, 5 times square root of 5x in the numerator. The 5's cancel out. So you have square root of 5x divided by x is your final answer. The ones that are in the middle, they're horrible. Now you could multiply numerator and denominator by square root of 18. At least for the square root of 7 divided by 18. Then you have to simplify it. Another thing you can do is recognize that 18 is 9 times 2. Square root of 9 is 2. Square root of 2 is square root of 2. So if you recognize that, multiply the numerator and the denominator by the square root of 2 only. And you already have your simplified answer. At the top here, same thing. We can multiply numerator and denominator by 32. And then you have to simplify, or you can recognize that 32 is 16 times 2. What's the square root of 16? 4. So 32 could actually be rewritten as 4 times the square root of 2. So all you really need to do is multiply numerator and denominator by square root of 2 to eliminate it. Why am I going over these quickly? Well, same idea here. And then, come on. And then we get to, well, some of these. So I've got the fourth root of 3. We need to eliminate whatever's in the denominator here. How do we get rid of that? Well, we need to multiply this by essentially 3 to the third. So you have 3 to the third times, or 3 to the third power times 3, that gives you 3 to the fourth. Same type of thing here, same type of thing there. Try to do one of these really quickly. So I've got 4, or fourth root of, 3 divided by 64. We can rewrite this as the fourth root of 3 divided by the fourth root of 64. Looking at 64, I can rewrite this a couple different ways. So fourth root of 3 divided by, say, the fourth root of 4 to the third power. I need to make this 4 to the fourth power. So multiply it by the fourth root of 4. Numerator and denominator. 3 times 4 is going to be 12. The new denominator here is the fourth root of 4 to the 4. So final answer here, 4 root 12 divided by 4. Is that horrific? Yeah. Does that take a lot of effort to get there? Yeah. So try to do another one of these really quickly. I'll do this first one here. So 1 over fourth root of 5. So again, I need to have this so that it's going to be 5 to the 4th power to cancel out the 4th power here. How do I do that? Fourth root of 5 cubed divided by fourth root of 5 cubed. That's going to give me fourth root of 5 cubed divided by fourth root of 5 to the 4. Those powers cancel out. So I end up with fourth root of 5 cubed divided by 5. So yes, is that ugly? Yeah. Yeah. Does it get worse? Yeah. And the next part is literally trying to eliminate radicals from the denominator. For a lot of these example problems that you're going to see here, you have to use that special property that we know of, a squared minus b squared. If you factor it, it becomes a minus b times the quantity a plus b. So with this, you multiply the denominator and the numerator by 1 plus root 5. Here, you multiply numerator and denominator by 4 plus root 6. That eliminates the radicals from the denominator, and you're good to go. If you look at this problem here, it's the same idea. So square root of 3 divided by square root of u minus square root of 6. So multiply numerator and denominator by square root of u plus square root of 6. Because a squared minus b squared is a times b, or a minus the quantity a minus b times the quantity a plus b. So they eliminate each other. So your new denominator here is just going to be u minus 6. Numerator is going to be a mess, but the denominator is actually going to be pretty nice. You can see what's going on there. So here, multiply numerator and denominator by square root of x minus square root of 2. For this one, multiply the numerator and denominator by square root of y plus square root of 3. The new denominator here is going to be x plus 2. The new denominator here will be y minus 3. And then it gets crazy. So again, multiply the numerator and denominator by a square root of x plus square root of 7. Using that special formula, your new denominator is going to be x minus 7. And they're showing you here that you can actually just say square root of x plus square root of 7 times square root of x plus square root of 7 and just square it. So what's the new denominator going to be here? P minus 2. What's the new denominator here going to be? Q plus 10. or sorry, Q minus 10. So. And that's the horror of it all. So if anyone wants their exams back, I do have them. If you want to talk about the grades you got on the exam, we can do that. But I do not have any take-home or in-class problems for you.